G'day everybody, welcome to another edition of Kev's Workshop. I'm around at a friend's house. Now my mate Steve Reeves taught me all my model engineering. Steve is the guy building this Garrett that's behind us. Steve's been working on this since about 1997, was it? 98?
Oh, earlier than that.
Earlier than that?
Yes.
But when I used to come around to Steve's workshop, and I was building my first 7¼ inch project called Bumblebee, it was a case of Steve was teaching me machining wheels, machining axles, putting everything together, and you've probably seen that in a previous edition of Kev's Workshop. So Steve is a guy that taught me my model engineering, amongst a few others. So what do you reckon, Steve, on your project?
Well, this is my big project that I've been working on for many years, and this is a freelance Garrett locomotive. So we've got the rear engine over here, a little bit off camera. You can see the cab, of course, the steel boiler for it, and then at the front engine unit. So this is based on two little tramway Garretts that were built by Peacocks in 1912. I've done my own version of it, if you like. So I've extended the chassis a little bit and extended the boiler a little bit. Everything you see apart from the nameplates I've made. So it's been a long-term project, probably still another 2 years, maybe 2 years to go before I complete it, but now that I'm retired I'm well on the way to making it happen. So there's a lot made and still a lot to do. So the first thing I show you guys is that's the Garrett full size built by Peacock, so I'm doing my version of that. And that was a little tramway Garrett. There were two of them that were made. So that's where we get the shape of the buffer beams from. Then this is the front engine unit, so it has piston valve cylinders. I based this all on Martin Evans's Highlander design, the black 5 and 7¼ inch gauge. All the motion work that you see here was done on a computer program, all designed on a computer program. Then we had it all laser cut out, and then I just finished it all off with hand files and emery paper. It's all made of stainless steel. Drove me nuts doing the emery papering to get the nice finish, but as you can see, the result was well worth the effort. In the middle of the engine there's a lot going on here. So the most obvious is the pipe work, of course, running down to the boiler. Now this is the steam coming in, goes into the centre of the cylinders here. This is the exhaust here that goes back out from underneath, so you can't quite pick it up with the camera. The two pipes that I have at the front here for the mechanical lubricator, I'm rebuilding that at the moment. Kevin just pans over, you'll see them on the workbench there. I wasn't happy with the drive system for them, so I'm rebuilding them. They've got little hand wheels on them, so you can do them manually, or the engine when it's running will operate it all as well. So you can see all the bits laid out on the bench here. So that's what I'm doing currently. Rightio, these are the oil headlamps used on the Garrett that I've just completed. They'll have some electronics in them. I'm going to put LEDs in them. Of course they should have an oil headlamp using whale oil in the old days. But we'll put electronics in it, so the door opens. It's also got a little slip door there. That's where they would light the wick, so I'll put a little switch in there to operate that. These are metal spun. These are actually vintage car headlights. So the metal spinner, I got it commercially done. He had a former which he bends the material over, and I've done everything else that you see.
There's certainly a lot of detail gone into it, that's for sure.
It's got to look right. Yeah, it's got to look right.
And down here, we just take a look at the little baby ones.
These are what's called marker lamps. So there's two white and two red. So The headlamp sits on top of the tank. Kevin will show you the tank in the next shot. And then halfway down the front of the tank is your marker lamp sitting on headlamps. Head brackets, I should say. On lamp brackets, get the termination
Correct.
right. Lamp brackets they are.
If you want to see how any of this is made, on Steve's YouTube channel, which is Reevsey Workshop, which is where I currently am at the moment, Steve will have currently 9-part video. It's going to be going out into umpteen number of parts.
Well, yeah, as I keep building, I keep showing video of what's going on. So I'm actually up to part 18, but I edit stuff and change things around, which is why I haven't posted yet. But every fortnight a video comes out on things that I've been doing, of which the Garrett, of course, is the main feature.
Alright, so what I'm going to do from these little headlamps, I'm just going to come up down the side of the Garrett. I'm coming back towards, you come into Steve's workshop. So that's the lead unit up here, which we've just been looking at. If I come around here, we've got the main smoke box, boiler and firebox area. To give you an idea, that's all the steam pipes on the inside. That lets all the smoke from the firebox come through to here. And then up in here we'll have a petticoat, as they call it, which will vent all the steam and smoke up out the chimney. So up into here. So there's a lot more to go inside the front. Down the side of the boiler, you've got these little plugs on the side. Steve will be able to tell you more about them.
Well, these ones are the water entry, so I'm actually putting a steam pump on this shelf down here, and that'll go feed water in here. And these are for the injectors, which are a steam device for putting water in the boiler. These are for handrails, so I'm going to have a handrail stretching along here, and I've still got to put the pieces in for the smoke box yet.
And up here's the steam dome. So for those who don't understand steam engines much, steam gets gathered inside here, comes down through the boiler out to where the regulator is, and then that goes down through to the front and rear unit.
So basically what happens, this big square section has an inner box, and in the inner box is the fire itself, and that's surrounded by water, and that's where the majority of the steam is made. Then the round section here is like an accumulator. So we call that the boiler barrel, and that's where the steam is stored for use, and then it's collected in the dome, as Kevin has just said, and then there's your valve, steam valve called the regulator, that controls the steam flow, and it goes down a pipe into this part, and in the Garrett it comes from underneath here, splits into two, and there are pipes that go down here underneath onto these pipes here. That's what these pipes are for. And if you want to lower down, this is a test piece I've used, but the pipe will actually interconnect here, and then another one runs down the back to the rear engine.
While Steve's firing up his air compressor to do a test run, to show you in the back end of the firebox, this is before all the other details go in. There's his steam gauges and such. His regulator will end up in here. This lever will select forward, neutral or reverse. So that's classed as a reverser. This stand here is for the park brake. And inside here is where the fire will eventually go. At this point you can see all the boiler tubes from the firebox end going through to the front where we were just a moment ago.
And you can see the plate work for the inside box on the sides and in the front as well, where the fire is and where it transfers the heat out into the water space.
Without shining the light in there, it's hard for anyone to see, but underneath here is where a fire grate will be and an ash pan. So the fire will sit on top of the grate, air comes up through the grate or over the top of the fire, depending how the driver does it. And as we get the heat through the fire, it becomes hotter. As we get the air over the top of the fire, it will cool it down. For those who know much about steam power, and this is the rear end, which is still nearing completion, I believe.
Well, both engines actually run on air, and the reason you hear the noisy air compressor at the moment is I'll give you a demo of the front engine running, The back one I've pulled some of the parts off to paint. If Kevin switches his camera over a bit, you'll see the last of the components there I've just painted. I'm just waiting for them to dry.
There they are.
There they are. So they're all off the rear engine at the moment. So the rear engine I can't actually give you a demo of it running, but both engine units are exactly the same stage and they're basically complete.
Oh, good timing.
Okay, so we're going to have to put the engine in forward gear before we run it, and we do that by using this linkage here. On a standard engine, what they call a rod engine, this would be called the reach rod. But in a Garrett, this is the pivot point where the chassis moves to go around a curve. So this has to be able to move as well. So I've got to be able to move sideways as well as back and forward. So if now it's all a bit stiff, but if I push it forward, what it does is it puts the engine in forward gear. So you see this component, I'll just pull it up again so you can see how it slides. Now if I put it up the top, the engine would run in reverse. If I put it down the bottom, the engine runs in forward gear. Now the motion work is made up of two components. So you've got your crosshead, so you've got your piston connected to your crosshead. This conrod, as it's called, is connected to the wheels, and then the wheels are connected together on coupling rods. And this is the bit that actually powers the engine, turns the wheels and pulls the train. All this section here is all to control a valve. It's up here, which is another cylinder with two pistons in it, and this directs the steam flow into the main cylinder to push the piston back and forth, and it also redirects the exhaust. So once the steam has done its work pushing the piston, it needs to be removed, and so it's removed on these outer edges here, which is why we've got these pipes here. This arm here is to drive the mechanical lubricator. So you need that valve, the piston valve, to move at a precise timing, otherwise the wheels won't turn round. So all those second parts I showed you control all that movement. Okay, so we're in forward gear now, so I'll just apply some air and you'll see the wheels start to turn round. You'll hear the compressor kick in shortly because it's not big enough to keep the engine running.
So looking at this from above, you can see how everything travels in a straight line. Something a lot of people don't realise, as Steve taught me years ago, that the right hand side leads by 90 degrees. So as one cylinder is either being pushed or pulled, the opposite one is changing over to the other rotation. So when one's pushing backwards, the other one's not doing the other. So it's supposed to be oscillating in some sense. Okay folks, now we're looking at it from a slightly different point of view, perspective, whichever you want it. You can see up here the valve spindle area, the compensating link, the radius rod, which is this area here, up into the expansion link, and the die block is what travels up and down inside all of this. So from this point of view, Steve's going to put it into reverse for you.
That's mid-gear. Reverse.
And you see that this valve position has changed.
It's actually moved this linkage forwards, so it's now opening a set of ports at the back.
Okay, so if we can run her again, but in reverse. So just by changing that valve position, you see how that changes things. Position of the crank, is this eccentric crank, that changes from the radius rod through the expansion link and through. That's how you change between forward, neutral and reverse.
So this is known as Volchert's valve gear.
Or wall shafts either way.
So this is the front water tank for the Garrett. I'll just show you how the marker lights go on. So I've got these little brackets, lamp brackets that bolt on there, and then this will slip on there. It's all a bit tight at the moment because of the paint, but once it slips down to its correct position, that's where they go. So you've got one here and you've got one here. And then if Kevin pans up, you can see I've temporarily put the headlamp on. It gives you an idea of how it all sits. All the same as full size.
And actually what we'll do, I'm just going to come around this side to start with to show you some of Steve's work. There's his little water filler hatch.
Yeah,
Now if you watch on Steve's videos, you'll see how he made all this. And down here there's a big hole that you can see into the water tank.
That's so you can get your hands in to clean things and get at things.
So it's an access hatch.
It's an access hatch.
Right, and down here is the foot plate which sits in this recess.
In this recess here, that's right.
So Steve has been putting a lot of effort and time into his Garrett, which he's been building for donkey yonks. So technically, I remember the Lego being partially assembled or partly started back in the 90s, here around 2026, and this is where he's up to. Now down here in the corner, Steve, do you want to show your audience and my audience?
So I've got to put a little bit of packing in here. You see it's not sitting flush at the moment, but this is an access hatch for the mechanical lubricator. So you'll be able to get at the top of the lubricator with your hand, pull the lid off, fill it up with oil, put it back on, and then shut your door down again, like so.
Bloody awesome. And the finish on the paint job is just fantastic.
Well, this is 2-pack epoxy paint. I actually had a friend spray paint all this part for me, and then the lining, you see, was also professionally done by a sign writer, and he used to work for the Hunslet Engine Company that built full-size steam engines for narrow gauge railways. So this lining is very, very much like what they did on full-size steam engines. I chose the red colour for something different. I normally paint my engines green, and I was getting a bit sick of green, so I chose red this time. And then it's funny how your eye works. So the shade of yellow is important because it must contrast with the red. So you can't put just any yellow on there. So that's like a what they call a lemony yellow colour.
Or yellow buff, isn't it?
Yes. So that if I chose something a different shade, it just wouldn't look right against that red.
Something I'm loving is the high gloss finish.
Yes, yes. Well, that's one of the advantages of spray painting. Of course, you can get paints in mattes or semi-matte, but I like everything gloss. So you saw on the engine units gloss black, and I like my engines to be nice and shiny. So this section here will always remain bright and polished. This will be a gloss black, so you'll see the brass will contrast against the black well, and that should contrast against the red well. So presentation to me is everything, so it's got to look like it's brand new and loved.
Definitely. And when you've got something like this which is high gloss, nice and shiny, it is very appealing to everyone who looks at the loco.
It does. People like to see shiny things.
Okay folks, for what you're looking at here, 3 different sizes of injectors. The purpose of these are to pull water from the tender or the water tanks and pump them into the boiler. They take low pressure and convert it into high pressure. And Steve, if you want to tell people how these work.
Alrighty, well what happens is these are based on what's called the Laurie Lawrence injectors that were published in the Model Engineer. The Model Engineer is a magazine for our hobby, caters for our hobby. I'm known as a model engineer, and the hobby and what you're seeing here is called model engineering. So this is the 1-to-1 size one which we use on our small scale locomotives. Then I did a 1.5 times 1, and then I did a doubled up one. Now these two here will be the ones that I put on the Garrett. So the smaller one is your one you use all the time to keep your water up. This one's like your emergency backup if your water level gets too low. How it all works is it's got a series of cones in here. You have water comes in this one, you have steam comes in this one. The energy of the steam is transferred into the water via the cones, and that forces it along here at pressure, and then it can go up into the boiler against boiler pressure.
And the long pipe off the bottom is the drain, isn't it?
These are called the overflow. So when you first turn the injector on, it needs the right ratio of steam and water for them to start to work. So at first the excess water flows out of here. Then when the injector does what's called picking up, that water suddenly stops, and that's when the process of feeding of the water through the cones starts to happen.
Okay, now over here on your bench, or one of your many benches, we've got down here all sorts of bits and pieces. Now for the audience may not know much about model engineering, would you be prepared to tell people what is what?
Well, everything you see is handmade. So if I take my green injector for instance, so all these individual pieces have to be joined together by what's called a silver soldering process, and you need to be able to hold them in place while you're heating it up and doing your brazing. So all this jig is designed to hold it. So we've seen 3 different size injectors. Here's 3 different jigs. Now when you come to drilling holes, so we've got to drill holes down here and up here and all that, we use another type of jig, which is this one here. And I've got pins to locate things, and you drill down through here, and that accurately locates the hole on there. The other thing we do is the cones that I was talking about need to be a special shape, and to get them a special shape you have these little reamers, tapered reamers, and you use them in a lathe. This is held steady, but the cone that you're making spins round, and then this goes inside and forms the shape up. And I've got several different sizes here because I'm doing several different injectors. They have little stops on them because that dimension there is very critical, so you've got to make sure it goes in at the right dimension to create the right shape. So this little stop, I haven't put that on this one yet, ensures that this is located in the right place. There are different angles, so I've got a selection of reamers here for the different angles that are used for the different cones. Now model engineering, as the last part of that suggests, is engineering. So that means we are machining up components from scratch. To do that we use machines like this one here. This is called a lathe. In fact, many model engineers start later in life, particularly when they're approaching retirement. But I started very young, and I was self-taught in the same way I've been teaching Kevin. I was taught too. When I first got a job, I didn't buy a car, I bought my lathe.
Get your priorities right.
Got my priorities right. So I rode around on buses for another year before I saved up to get my car. So this machine, you put what you want to machine your part in this section here. This is called a chuck. It will spin, as you can see. As it's spinning, these tools in here, so you see this moves in 2 planes. So that tool will machine the component to the shape that you require. If you need to drill holes or anything like that, that's what this section does.
So I've got myself a Myford lathe at home. Steve's had this Myford lathe for an umpteen number of years.
I have. This is what's called the Myford ML10. This is a smaller version of what Kevin has. Kevin's actually got the more Rolls-Roycey one. The Super 7 is the one we all like to use, but I couldn't afford to buy that on apprentice wages, so I got the ML10. But it's a beautiful machine. It does all my accurate work for me, so and that's why I've kept the machine and I still use it today.
I believe there's a special story with this.
The story is I bought it before the car. So I saved up my first year. I apprenticed as an electrician, as a motor rewinder, and my first year's wages went on to buying this, and this was actually the last lathe at Atkins Carlisle in Fremantle sold, because the Asian market was starting to come on board and you can buy machines from the Middle East much cheaper than you can. This is an English lathe than you can. So they were phasing out the Myfords and introducing the Asian machines instead. So I was very lucky to get it actually.
Yeah, when I got my lathe, I got it second hand. And it's the same sort of lathe I used to play with at school.
That's right.
And I done my high school.
That's right. And there used to be an Australian version of the Myford that was in the schools as well.
Yep.
Same size.
At least looking at here, we see Steve's Garrett. Steve's in the background here. Now, when I used to come around to Steve's workshop back in the 90s, I used to use the lathe that he had before here. This is Steve's bigger lathe. So I'll let Steve talk about it.
Well, as you can imagine, to build a big engine like the Garrett, I'm not going to do it on my little Myford lathe. You need something a bit more substantial. So I also bought this bigger lathe. This is called a long bed lathe, so you can see it's quite long. And this here, which is called the tailstock, can be moved back quite a way, so I can put big components in here. If you look at the little lathe, I have a 3-jaw chuck on it. At the moment I've got my 4-jaw, so 1, 2, 3, 4 on here, and this is designed to hold unusual shapes. But the rest of it is the same, so you've got tools in here, these move back and forth, so it's just a bigger version of the Myford.
If I'm right, this is the quick release setup, is it?
This one's called a geared head. When Kevin used to come over before, I had a very similar machine to this. It was a little bit smaller and it had a belt drive, and you had to lift the lid, change the belts over and put the lid down for this to turn. This one uses gears instead. So that's in high gear there now. I'll swap it over into low gear, and then you've got your speed selection, so you can do several different speeds. Now these lathes are also called screw cutting lathes, so you'll see this twirly bit here, it's called a lead screw, and you can cut a thread with that. So it has a gearbox on it here, and you can see the chart here. So if you buy a nut and a bolt, that's already got the thread on it, but I can make my own threads by using this gearbox and a special tool held in the compound slide.
Now the best part about this one, this has power across as well as leading back.
It does. So this other shaft here is designed to drive this wheel and this wheel. So I can set it all up to automatically move on its own when I need to make parts, which is very handy, because if I'm doing a slow moving part, what I'll do, you've got to watch the machine all the time, but while it's machining something, I can quickly go over to the mill or somewhere else and set something up and then come back and adjust things, so it's handy for that.
Awesome.
But the idea behind that is it gives you a better finish, because you set your feed rate up to the material you're cutting and the type of cutter you're using to cut that material, so it's all related, and it gives a better finish than if you're doing it by hand, which the other machine is all done by hand.
Yeah. Now, if I'm right, this cone shape you've got in the tailstock, is that for your headlight?
No, what this is actually a pipe holder. So say I want to machine something round that's got a hole in it in here. That's tapered so it can fit, the pipe can fit on there. It doesn't matter what diameter it is. But the reason I've got it in at the moment is I've been spray painting, and you're supposed to hold your cannons and shake it for 2 minutes. But what I've been doing is putting it in here, pushing that up against there and holding it in place, turning the lathe on, let it stir the paint up.
Another use for a lathe. Yeah. Bloody awesome.
Yeah, that's right. So normally you would have these here, would go in here. So this here is my keyless chuck. So you can put a drill in there, and you can see I can tighten it or loosen it. This is called a centre. So sometimes what we do is we don't actually use the chuck. We'll put the work, if it's a post for instance, it'll sit in a centre. So you drill a centre piece which that fits into, and that sets that up precisely in there, and as you're machining the features on the outside, it's a more accurate way of holding things. So I've got a few, and then I've got a standard chuck here with a key in it.
Have you still got your lathe dog?
I have. That's actually down here. I'll grab that.
Now for my audience, more so, if you're not into machining and you're not into lathe work, you wouldn't know what a lathe dog is. But when you're turning something between centres, you usually put a dead centre in the chuck or a faceplate. And
I'll
usually
just grab the faceplate out.
Yep.
Let's show the viewers the faceplate. I don't want to damage my lathe here, so I'm going to put it on here.
Yep.
So that's your faceplate, and then what happens is your centre goes in the middle. And then let's say I'm going to turn this piece up here. This is the dog. So the dog screws down onto that piece you're going to machine. You'd have a driving post here, which I haven't bolted on. That goes on there, engages with that pin, and that's how you're able to turn the work. So this spins round, this sits where that would sit and spins round, and it spins that around, and then of course you just go along and machine your items from there.
That's awesome. I've got to get myself a lathe dog one day. I've got the faceplate, I haven't got the lathe dog.
Oh.
One day I'll get it.
Well, there's one other thing I can show you as well. I'll just very quickly take this off.
Yep.
So you can see a lathe is a very versatile machine. It does a lot of different things. Oh, it's not in that one, it's in the other one. Somewhere, wherever I've hidden it.
Probably the safe spot with everything else. I've got that many safe places I can't find anything anymore.
Yeah, must be. Oh, I've got it wrapped up, that's why I can't find it.
For those of you watching this video, I'm hoping you're enjoying seeing engineering from a different point of view. Again, you know, like Steve's #1 project is his Garrett. We'll do a proper tour of his workshop in a moment. And just a sneak preview, there's a couple of other locos we'll look at in a moment.
So I finally found my piece, which I put away. Always put things in cloths and keep them well oiled. That's a big secret to using machines. So this is what's called a fixed steady. So with long pieces they could flex in the middle. So what you can do is you put them in the middle here. And these three here will rub on the job. So you adjust them through this, and that holds that rigid while you're machining here or machining here. So it's probably something you haven't got on your lathe. I haven't got it on my little lathe either, but
no.
The bigger machines come with these as well. So there's quite a few different attachments that go on to lathes. The other thing I can show you is the quick change tool post. So I'll just take that down.
I'll come around the other side of you.
Yes, you need to be on the other side. So this is the quick change tool post here, and I'll just grab a couple of tools.
There's quite a few in Parliament. Every government's always got at least one. But yeah, folks, I used to come around here to Steve's workshop back in the 90s. And Steve taught me so much of model engineering, and I've learnt from so many other people as well. So, basically, when you see my rail car or my 7 1/4 inch or anything else, you know where I've got my knowledge from.
And you've built it on a machine like this. Like the bogies, the wheels were built on a machine like this.
Oh, definitely. And I remember coming in here so many Saturdays just to do that.
That's right.
Over, what, 5 years I think it was?
Easy.
3 years on Bumblebee and another 2 on the bogies.
That's right, yes. So here we have two of the turning tools. So this one is used for machining that way, and this one is for cutting the work into halves. So as you're doing machining, you want to be able to alternate between your different types of machine tools very easily. So you do that using the quick change tool post. So what happens is that slides in there, locks into place like that. I can now do my machining. Now I want to do a different machining operation. Take that off, swap it over to the other tool, lock it in place, and away you go. And this is a very quick, time-saving way of doing your machining operations, and it's all set up in a critical manner. So the top edge of that tool has to be a certain height off this edge here. So this will also make sure your tools are located exactly in the same place each time. So it improves your accuracy as well. Poor Kevin didn't have that luxury when we first started. I had a different type of tool post on there. We had to do it the old-fashioned way.
Like I've got on my one.
Yes.
Now for those of you watching the video, this is classed as a parting off bit. So when you're cutting off the excess, or you're cutting your workpiece off the area that you're machining from, this will cut a certain width until you get right down near centre, then it'll come off. So in this case, Steve's got the 4-jaw in. I normally used to work with a 3-jaw, but when you finish doing your work, you use one of these parting off bits to cut.
Now something else that may interest you on my little lathe, you see this is a different material. This is also a parting off tool, but see it's shiny. This is made of what's called tool steel, which is a softer material. It's still hard and it still has to be ground, but this one here uses a tip tool. This is a ceramic tip, so I can cut bigger pieces of material off at a time. So the lathe is bigger, it has more force when it's machining, so that's ideal for a tip like this, whereas the other one that I showed you, this one here, that's really for light work, so that's why it's used on the smaller machine. But again, you can see I've got the quick change tool post on the little machine as well.
Awesome. So we'll do a tour of Steve's workshop properly in a moment. We'll show you when Steve's ready.
Well, what we'll do is, as Kevin's winding back, we're looking at my mill drill. Probably the next machine that you would use after your lathe is your milling machine. This is not quite a milling machine, this is called a mill drill. So it's got this round post on it instead of a dovetail. It's the cheaper version of a mill. When I bought my milling machine, it cost me $2,000. In those days, to buy a proper milling machine was $9,000. So I couldn't justify the cost. Today, with the introduction of the Asian market, you can actually buy machines this size or smaller that are proper milling machines, and they're better to use because they're more rigid and they can give you a better accuracy. Now I've been drilling holes in this one, so I've got my drill in there. What happens is a milling machine can machine up and down, side to side, and back and forward. So it's in three axis. That's right. So, and it can be used for irregular shapes as well. So the lathe is really specialised for turning round things. A milling machine is specialised for turning odd-shaped things. Now, if Kevin wants to pan around, this is called a digital readout. Now, this is something I've updated my machine with recently, and you'll see everything's digital. And if I move something, you'll see the numbers change. So I can accurately position the work where the milling cutter is, and then I can go back to the same place again, and it works in 3 planes. So we have what's called the X plane, which goes that way. We've got the Y plane, which goes that way. You can get a digital readout with a third display, but I actually use this one here. This is also digital, and that gives me the Z, which is up and down.
Okay.
Now what we can do,
And if anyone knows what a shop press is, this is a shop press. So it goes in any workshop. This is a floor standing shop press.
most people probably be seeing them
Yeah.
in automotive videos. So a mechanic has these, but we use them like pressing the wheels onto axles. You'd use that for that.
Yeah, and there's a hole for an axle to go through, basically. So
That's right.
we can set it to any diameter. You could use the V shapes as well if need be. Put the wheel onto the face, and then we can push the axle off, or we can turn it face down, put the axle on.
That's right.
And then for those who may also wish to set their own workshop, bandsaw.
These are very handy. They don't cost a lot of money, and you use them continuously.
Yeah.
So you've got a blade in here that runs continuously all the way around. If I turn it on,
I've got one of
You'll
these at
see.
home.
you'll see it working there. So you put what you need to cut in there, you bring that on, turn it on, and away it goes, it cuts it. Then when it finishes cutting, it trips a switch and turns itself off. Very, very handy machine.
And for when you've got rough cuts that need trimming up, Steve's also got linishes.
That's right. So I've got 2 types here. I've got a little baby one here. So this is a sanding belt here. There's also one on the end. And these tables are set up accurately so you can hold the work, if I just use my finger as example, against the
Sanding belt.
sanding belt. It'll give you a square shape. Or you can do curves as well. You can turn the job around like this and this and curve it. This one here you would see in a more in a woodworker's shop, but these are special sanding belts for steel, not for wood, and they're a finer grain. But it's the same idea as this one. So I've got one here and I've got one here. On the other end of it I've got what's called a conditioning wheel, and that's used for polishing things up and cleaning. Now this machine here is called a grinder. You can see I'm running out of space, that's why it's sitting at 90 degrees. But what this does, you saw the tool steel I talked about in that parting off tool. Well, how do you grind the shape? So the angles of the shape of the tool is very important depending on what material you're cutting, and you grind them on these wheels. So this is called a roughing wheel, so it's got a coarse grain on it. This is called a fine wheel. So these spin round. So you do your first lot of shaping on here. So this has to be set accurately against there. And then you come along and you do your final cutting and shaping using the fine wheel. And then you'll get a stone. You may have seen in videos people polishing a knife or a blade or some kind. They've got a leather belt and they'll go back and forth on a leather belt. Well, we use a stone instead, but it's the same idea. So you rub the tool against the stone, that gives you your final edge, and then you put it in your machine and use it for making your parts.
Well, do you want to do a guided tour of your workshop?
Well, we can go to the brazing bench next.
Yep.
Okay, now this is something I've just recently acquired before I retired. This is a 3-in-1 machine, but when you're doing sheet metal work, so like the cab on my Garrett is made of sheet, you want to be able to bend it, put corners in it and things like that. You want to be able to cut it to shape. So this machine has what's called a cutter here. So it's got a blade that moves up and down. You see it moving up and down. A guillotine is the correct term I'm looking for. So you would put your bit of sheet in there, turn the handle, it goes clonk and cuts it off. If you want to do a round shape, we've got these 3 rollers here, Again, if I turn that handle, you see the rollers are turning. They're adjustable to give you different radii. So I can do rolling action as well. And it's also got a bending action in it. So say I want to bend a corner. You can change this blade. You put your piece in here, and as you move the handle, it bends it. So say it's flat like that, and then it'll bend it like that. So it bends it up to whatever shape you want. So
Whatever angle.
whatever angle that you need.
What's this on the end here?
This is a roller. So this is
Oh yes,
it's got a groove in there because it does round bar.
yes.
But it's the same principle as the other one there. So
So
that's got 3, and you'll see this has got 3. So you can put something round in there. You turn your handle, there's your handle there, and it'll feed it through, and as it feeds it through, it rolls it into a circle.
Yes, that's right. Yeah.
And I can use it on flat plate as well. So when I make springs, for instance, you have a look under a trailer or even under your car, and you'll see it's got the what's called leaf springs on them. How do you make that shape? Well, you use a machine like this to do that.
Yep. So that's 2 sets of different rollers at least.
2 sets of different rollers, yeah.
Yeah. Okay, we've got all this stuff in the background here, so
Well, all this
skip
stuff
through.
here
storage.
is these are all your tooling that you use. So I talked about the quick change tool post earlier. Well, here is other selections of tools. So there's too many of them to leave over by the lathe, so I've put them on the shelf here. So you can see I've got a range of different tools depending on what sort of jobs I want to do. Now the other thing you use is what's called a collet set. So here's a collet, and what happens is you put that in the lathe or your milling machine in a special chuck, and you clip it in place. The job goes in there, and that holds it precisely, and you can pull it out and turn it around and put it back, and it locates it very accurately. So I've got a big set of collets sitting there, and I've got a small set here which I use on the smaller lathe. Up here on the top here are all our measuring gauges. So this is made to a precise diameter. It's very carefully ground. So when I'm drilling or boring holes, I might want to make it to an accurate tolerance, like Kevin was talking about pushing wheels onto axles. Well, you want to make sure the hole in the wheel is an exact size, so it'll be a tight fit onto the axle, and you can use these gauges to measure your hole size to make sure you get it accurate.
For a lot of you out there watching this video, Steve's been doing this since don't know when.
Well, see, I'm unusual because I started when I was a teenager.
Yeah.
I've been doing it for 15 years now, so everything you see here is
Accumulation
of that 50 years.
Yeah. Also up here, if I'm right, looking here on your fridge door, is that Sarah?
That's Sarah. Yes, in America now I'm painted black. It used to be green. In fact, I'll get Kevin to show you a poster of what it originally looked like.
Now, for what I remember of Sarah, when she was Steve's, she had a nicely varnished cab, and now the cab's green.
Well, the guy actually contacted me not too long ago, because he found out I was the original owner, and he said he had it out in the bush in a shed. So he lives on must be on a 5-acre block or something. They had a storm come through, tree landed on the roof of the shed, smashed the wooden cab. So he's had to rebuild the cab. Yeah, but he just done a good job. You look at it closely, it's very nicely made. Didn't damage the rest of the engine, it was only the cab.
Yeah.
So he put the new cab on and painted it black.
So
that's the story there.
yeah, so okay. Bear with me. I'm just going to change camera position.
So this is Sarah when I owned her down at Castledare Miniature Railway. You can see the original cab on it, lovely wooden cab. That was actually made by a lady carpenter, very skilled person, and it had the green with the same yellow lining that I'm putting on my Garrett. That engine was actually bought. I cheated and bought that engine, but I had it for 11 years and ran it at Castle there, and we've had some many fun times with that engine. I still miss not having it today. So this is my drill press, like the bandsaw. This is a relatively inexpensive machine to use, to buy, and you use it all the time. So this is for drilling holes. So I went and bought a nice machine chuck for it. So you put your work, you want to drill the hole into here. You can see the jaw moves back and forth to hold things. Then you put your drill in here and you go up and down to drill your hole. It has several different speeds on it, so I've got a belt drive up the top that changes the speeds, and then like a night light, if you like, a little lamp there so I can see the work.
Okay, now Steve's also got over here, folks, some of his little model engineering.
So what we like to do is we like to go out and promote the hobby. So my club, Northern Districts Model Engineering Society, will take a model engineering display. So that's basically a table or a few tables of our work. Obviously they're not the big things like the Garrett. People will build small items too. And I like to animate the display to get people in to have a look at what we're doing, and I do that by using these steam toys, which you've probably seen before in other videos, and I've just been doing them up because they stopped working on me and I didn't have time when I was working to repair them, and I'm just gone back and started repairing them. So I put them on a nice Jarrah base. I've done all this section up here, and I've changed a few things here. I'm waiting on some tools that I bought off the internet so I can screw this little thing back in here again. This one here unfortunately got boiled dry.
Oh no.
And was damaged, so I've had to resolder it, so you can see all the solder running around here. And I'm ready to repaint it now, so I'll repaint it and make it look nice again. This is actually an Australian toy built around World War II. Still goes strong.
Beautiful. Well, for those of you watching this video, I will be putting up a AMRA exhibition video. The AMRA Western Australian Branch Model Railway Exhibition will be the 20th and 21st of June in 2026. So sometime after that I will be putting up a video, and I'll probably get some video of all this in Steam.
Yes, should have it all running in Steam, and I've got a few other items which I can show you all as well. So we'll do a little quick video on our stand and the things that we have on it. Now this is my battery electric loco, 7 1/4 inch gauge. Now most model engineers like to hand make things and run them, but I like getting involved with running trains at railways like Kevin does, and I'm sure Kevin's shown you some of his activities there. So I cheated and I bought this from the UK. But it's a 6-wheeled engine, so it's got electric motors underneath that are geared, and then
I have a sticky beak up under here.
Underneath.
It's a bit dark, but you get the idea of it.
And then I've got these smart chargers that I bought off the internet, which what they do is they sit here on idle and then they test the battery voltage. You can see the orange battery in there. These are not car batteries, by the way. These are deep cycle batteries, which are a bit more beefier than what you would use in your car. So these smart chargers can tell when the voltage is too low, turn on automatically, charge up, and then turn off afterwards. I'll lift the lid and you can see some of the electronics inside here.
Now I'll skim up around here.
I've customised the engine a little bit. I put this amp and voltmeter on here.
That's something I've got to do in my rail car.
And then of course here in Australia the temperatures can get quite high, so I put these cooling fins. This is the speed controller here. This is what's called a sound card, so you get a diesel sound. So when I start it up, you can hear the diesel turn on and run. So I put cooling fins on them as well, and switches for the headlights and a few other things. So I customised the engine a little bit to suit Australian conditions.
Yep, you've done well. Now, in the body shape, it's a little like a New South Wales 70 class,
Yes, yes.
but it doesn't have the outside rods, which is interesting. But regardless, you know,
It'd be nice to have the rods on it.
oh yeah, that's something I know you'll end up doing eventually.
Probably will, yeah.
Now, here on the end of the buffer beams, or pilot beams, we've got two lots of plugs. What's the one on the left and the one on the right?
Okay, so when I modified the engine, it had the controller for it, which is down here, had electronics in it to operate the headlights and a few other accessories. But when I went to rewire it, you can only get cable with a certain number of wires inside it. So I had to convert some of the switching into the engine itself, and then the rest of the switching is on here. So I've got the horn, it's forward and reverse to turn it on and off, and this is your speed, controls your speed. So I needed 9 wires to do it, and you can't get cabling with 9 wires, you can only get 5.
I've got 8-pin DINs on my
You
rail
can
car,
get 8 pins,
yeah,
but you use smaller cable, so that means smaller current. So
correct.
for you, that's probably okay for the type of controller you're using. But for this particular controller on here, I needed higher current.
Yep.
So I used bigger wire,
Yep.
and that can only be bought in 5 core, as they call it.
That's right.
But the original was like Kevin's, so you can see that's an 8-pin one.
That's all just coming to here.
So that's an 8-pin one, and that uses the smaller size low current cabling. And I've kept that so I don't put the wrong plug in the wrong socket. So you see that's a 5-pin.
Yep, 5-pin DIN.
And then the 8. So now I can switch them in the right way.
Awesome. Now I'm also just spotting up here the LMS tender.
Well, this is a club project, so one of our members built a 7¼ inch gauge Royal Scot. If you're not sure what a Royal Scot is, go on to the web and it'll bring up on Wikipedia the history of the engines. They're an English designed engine.
There's obviously where the driver's seat sits.
That's where the seat. So this is the tender for it. So this has water in here and coal in here for fueling the engine. It's been painted the same colour as my Garrett by the same person that painted it for me. And then I've had it over to the sign writer. So it's got the same lining on it that my Garrett has. And then he put these LMS.
That's come
London, Midland, Scottish Railway.
That's come up beautiful.
It has. He's done a top job of it. Really has.
Okay. Well, I'm going to say thanks to Steve for the tour of his workshop and a bit of insight. This is where I learnt to do my 7¼ inch when I started. And up the back here we've got some other projects that Steve's got to get onto one day.
There's always more projects to do, and we have to be careful because we can think faster than we can build, and you tend to have more projects than the life that you have.
So true, so true.
And you can see I'm very active. I've got about 4 projects on the go at once here.
Yeah.
So it's a bit of a time management thing to make sure they all get completed. But I like having several projects going because you work on one thing all the time and you can get bored with it because it takes a long time to build things, as you can see with my Garrett. Lots of components to make. So it's nice to swap over to something else for a little while and get a change, and then you can swap back to your main project. It's also good for problem solving, as you can imagine. As you're putting things together, they don't always work exactly as you intended or fit together as you intended them. So you've got to think about, well, what do I need to do to modify it and change it around? And you can get in a rut, you can get stuck in you're not sure how to do it. So if I go and work on the little steam toys, for instance, a simple project, I can work on that for a little while, and then when I come back I feel refreshed, and then I think, oh yeah, that's how I can solve that problem, and you go and solve your problem, and then you go and build the part and whatever you do. So having more than one project can sometimes be very, very useful. But of course the trap is not to have too many, and you're moving from one project to another continuously and you never finish anything. So you've got to make sure you stay focused on your main projects, which in my case is the Garrett, and then I'll go around and do other little projects in between as I need to.
Okay, so folks, one final look at the Garrett. So when you come on, look through all my videos, there should be in my subscribers list, Reevsey Workshop. If you can find it, open up a second viewing tab, and that way you've got two browser tabs open, and you'll have my channel, LocoMan3801, on one of your tabs, and a second tab you'll have Reevsey Workshop, and then you can get a comparison between them. Now I've got my website called Kev's Workshop, locoman.free.nf as the website, and then not only do I put a lot of stuff on there as far as photos and that, but to keep an eye on Steve's YouTube channel, you'll be able to see the progress of this. At this point in time he's got 9 parts up on YouTube with more to go, and it could end up over 20 parts worth. But if you want to follow Steve's project, that's the way to go. And you'll find Steve on Facebook, I think.
Yes, I'm on Facebook as well.
Yeah.
Steve Reeves it is, and then I'm sitting behind one of my engines on a, and so you know that's the one to pick, so I'm sitting there with that engine.
Yeah, and then if you go to Northern District's Model Engineers in Balcatta, Western Australia, you probably see Steve up there on on the run days. And Steve can also be found down at the Castlederg Miniature Railway, I believe.
Oh, not Castlederg. I go down to Bunbury, so
Go down
Forest
Bunbury now.
Park Railway.
Okay.
Is where I go now.
So the Forest Park Railway is the other place that you'll be found.
Yes, and that's what I bought the little electric loco for, so I can, because that's a 2-hour drive, it takes a long time to get a steam engine in steam, so it's handy to have an electric loco, so I can put that in the back of the car, drive for 2 hours down to Bunbury, unload, and I'm away passenger hauling in about 20 minutes, so it's very handy for that.
Yep.
So I like to run my steam engines up at Northern Districts, also known as Stirling Miniature Railway, so if you can't find Northern Districts, look up Stirling Miniature Railway. So I like to run the steam there, and then I'll run the electric down at Bunbury.
Cool. Thank you very much everyone for your patience with us. Hopefully it hasn't been too long for you or too boring. Hopefully we've been entertaining and hopefully informative. And this is basically the workshop I learnt my engineering in. Thanks for your time and everything, and we'll catch you on the next one.